Hello and good afternoon. Welcome to a new episode of our columns recreation game in SpriteKit. And today we'll work on controlling the falling gems, in particularly moving them left and right. So let's see what we have so far. First, let's see if all our tests still run and succeed. Okay, so these still succeed. Let's look at what we have in the game so far. Okay, so we have a stack of gems falling down until they reach the bottom, and then some other ones get spawned, etc, etc. But a bit boring if we can't control where they are placed. So controlling them is two things. It's moving them left and right. It's also changing the sequence of the gems. And today we'll work on controlling the falling gems by moving them left and right. So in our board tests, let's create a new section to control the falling gems. And our first test will be when left is called, falling gems are shifted one column left. So we need a board, and we immediately call update. So we have then we also have a column of gems falling down, and then we create a shifted board. So that's one where we put some input in. We take our board and we call the function called left. And this function doesn't exist yet, but we can create at least a placeholder for it. This should return a board. And now this one can compile and we can continue working on the test. So what we want to check is that after we call left, that the gems colors should be the same in the shifted board position as in the original board. And that's x minus 1 because we shift them one column to the left. So we can assert that in our shifted board, our add factor, let's see, 2 and 13, because we start at 3 and then we move left, that would be 2. This should be the same as what we have in the original board at 3, 13. And we should have something similar for for 14 and 15, and 14 and 15 here as well. Also, the original positions in the shifted board should now be empty. So we can assert that positions like this one for the shifted board are now nil. And let's run the test. So this test fails because, well, we didn't do anything yet. So let's go to a board and let's start working on making sure that we can have gems falling down. So let's start implementing this left function. Let's create an updated board. That will be a copy of a board, and then we will return our updated board. And what we will do so far is we'll take our updated board and we'll look at the gems at position, the positions that we need, and make sure that this is the same as our current position to the right. So this hard codes moving things over to the left, but it gets us partly where we need to be, and we need to make sure that we have in the original locations, so where x is 3, we make these nil. That's 13 and 15. And let's build and make sure we run this test. Okay, so wow, we are able to move to the left, but in practice really only once. So this is a good start, but we're nowhere near finished. Because what if we, when left is called, falling gems not in original position are shifted one column left. So we can do more or less take the same test, but let's call update a couple more times so it falls down a bit more often. So let's say 4 times. Then these should be at 10, 11 and 12. 10, 11 and 12, because we fall down 3 times already. 11 and 12. And if we now run this test, this fails because we are hard-coded moving a couple of tiles. To solve this, what we can do is we can keep track of the falling stack bottom. So this can be an integer. We can start it at 13 because that's where we spawn gems. And then instead of using these y values directly, we can take our falling stack bottom and add, for instance, for the first one nothing, and the second one we can add 1, and the third one we can add 2. And the same here. And let's see if this helps. Well, at least the first test still passes, but the second one still fails, and that's because we also need to update the falling stack bottom when a gem has fallen. So else, if a gem has fallen, Then we do our updated board, falling stack bottom. We decrease this one by 1. Let's run the test again. Okay, so now it succeeds. So now we're able to move gems left, basically regardless of where they are in the third column. But what if it's not, what if we are already if we move very far left? So let's say the falling gems not, when left is called, falling gems that are in column 0 don't move left. So let's say our shifted board is left, 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 left. A lot of times, way more than is needed to get to the left one. Then we expect these not to be nil. Because we shifted all the way to the left. And this doesn't work because we, oh, wait a sec, I'm sorry, this is all column 0. We're never reaching column 0 because we keep working only on the third and second column. So we need to make our code a bit more general first to at least get a start here. And we can do that by taking our falling stack bottom, and instead of making this an integer, what if we made this a vector that starts at 13 and a y value, a y value of 13, and instead of decrementing it by 1, what if we are able to take our falling stack bottom and move it down 1. Okay. Then in our updated board, what we can do is, instead of the hard-coded 2s and 3s, we can take our falling stack bottom plus up, but up doesn't yet exist. So let's create a static variable for up. Plus up twice. And we can do the same here. And then we can take a direction. And this will be, in this case, left. One we also need to create. And let's add right for good measure as well. Then we have our direction here. So this is a vector. And we can do something similar on the left side as well by taking our falling stack bottom, but this time appending the direction. And we do the same for the second one. But this time we also add an up. And for the third one, but this time we also add an up and an up. Let's see what happens. Well, at least the previous test should still pass if everything is correct, but the second one doesn't yet. And the reason is we should check if we are already at the bounds of our play field. So if we say guard falling stack bottom dot x plus direction dot x should be larger than 0, or else we return ourselves unchanged. And finally, we need to take our updated falling stack bottom and actually add the direction. Oh, we haven't implemented that one. So we'll do it the manual way. Let's see if this helps. Okay, so now the test passes. We can move to the left, but no further than 0. That's nice. And yeah, let's do something similar for moving to the right. And let's go. Let's take this one and say when right is called, we move one to the right, meaning that these should now be 4s. And we need to create a function called right. Okay, so this test fails. To make this a bit general, let's rename this function to move into a direction. And let's create the function called left that returns a board that does move to the left. Now all the existing tests should still pass, but the new one doesn't. But if we say move to the right, this one passes as well. Okay, let's continue. What we also need to make sure is that when right is called, let's see this one, but for the right hand side of the playfield, and we are in column 5, then we don't move right anymore. So this will all be right. So this will be column 5. Let's run the test. And it fails, no problem. We can just augment our guard statement that we also want to check that the following stack bottom.x plus direction.x is less than the call width, or the number of columns, and that is 6. Okay, now these tests pass. we are quite someplace, but what we haven't checked yet is, for instance, func, if we shifting columns to the right can't overlap with existing gems. So we have a board, and then we need some stable gems, gems that don't fall down anymore. So we can have some at 5, 0, for instance this one is green, and there's one that is red, and then we have some falling gems. For instance, at 4, 2. This one is yellow. 3 and 4. Purple and a blue. And I make sure that they only overlap a very small bit. At least if you would shift this one right, the yellow one would collide with the red one, and then I don't want any of the gems to move. So we'll take a shifted board. And then we need to check that our shifted board at 4, 2 is still the same as our at the existing board. So basically we're saying the board didn't change. So let's, we should compare the same ones to each other. Okay, this test passes. Oh, we need to move the correct direction. The test passes. That is not what I would have expected. Oh, and we need to make sure that on our board that the falling stack bottom is at the bottom one of this small stack. I think this will make the test now fail. Okay, this shows how important it is to see if tests actually fail before you can make an assumption about whether your test does what you expect it to do. So we need to check if this location is actually if these locations are actually not occupied. And to do so, we only look at the bottom of the falling stack, because there will never be any holes in this game when a stack is falling. So we only check the bottom one and see if that one would collide with anything else. So we can use a guard statement that if a falling stack bottom plus direction, this should be nil, basically an empty space. Otherwise, we return a self. So let's run this. Oh, I'm sorry. I mean, run the test. And then I think we need to do one more test. We need to make sure that if a new group of falling gems is placed, that we reset the falling stack bottom to 13.2. So let's create a test that validates this. When a new stack falls, falling stack bottom is reset. So let's take a board and let's update it a lot of times. And let's do this while board.gems is smaller than 6. We do board.update. This calls update until we have 2 stacks. Oh, board.gems.count. And then we should assert that at that time board.following stack bottom is equal to 3 and 13. Let's see if what this does. So this test fails because it's at 0, because that was the last time where it was updated to, right here. So when we create, when we spawn new gems, basically what we do is we reset the following stack bottom, and let's run this. Okay, so the test now pass. I think it would be nice to add some UI so we can see this in the game as well. So let's go to our content view. Okay, get rid of this one. We now need a Z stack where we can wrap the sprite view, and on top of the sprite view we can do a V stack. We'll add some space. Then we'll do an H stack that takes a button. This will call a function called sceneLeft. We'll create it in a bit. And this one has a label. We'll use an image, system name, arrow shape, left fill, and the text left with some spaces. I did a check to see what sort of looks okay. We need a foreground color. Let's give it the accent color, some padding, a background, for instance secondary color, a clip shape, this can be a capsule, and a shadow. For radius 10 is fine. Then we have a spacer, and then we have another button like this, but this one is for right. We have the text right. This time we do the text first and then the image. And I think we have our V stack here. We can do some padding around the menu part well and give it nice and large fonts. And this is a bit of a trick, but we can add some text and padding to create a bit of offset from the bottom. So let's see, so we need to implement these functions. This also means that we need to create the scene in the content view. So basically we take this function, this call, and place it here so we can pass in the scene. Now we have a scene but we don't have the correct function yet, but let's go to our game scene and let's create the correct functions. And right. And let's see, let's build a run. So let's see what this is. So we have a left button, look, and we're moving left, and we have a right button with the wrong shape. Okay, so we can sort of start play. Look, I can't move through other ones. I can move to the right, but can't go out of borders. I can move to the left. So this is our basic controls done. I want to leave it here for now, and I'll see you in the next one when we will work on cycling the gems, so you can change their sequence in the following stack. Thanks for watching and have a good day.